Hi everyone, we are in section 7.5, Rationalizing Denominators and Numerators of Radical Expressions. Now, this is basically something you're going to need later on in other math courses so that you understand how to rewrite these in the proper way. So before we get started, we have to look at some facts that you just need to know. We teach what you need for this section because section 7.4 had some of this information. All right, so here's what happens. If we're multiplying radicals, as long as they are like radicals, which you can see these are all square roots, then I can take the square root of 5 times the square root of 5, which would give me the square root of 25, and of course the square root of 25 is 5. Same thing here with the 2's, right? 2 times 2 is 4, so that's the square root of 4. The square root of 4 is 2. Now, I'm hoping that you're seeing the pattern here because we don't really have to do that second step, right? I'm going to show you this one, right? If I multiply the square root of x times the square root of x, I get x squared, and the square root of x squared is x. So let's just take that shortcut on this last one. If I'm multiplying square roots and they're exactly the same, my answer is always going to be what's called the radicand, the part underneath that radical. Now, when I get to something where they're not the same, right, I have the square root of 7 times the square root of 3, I can multiply them because they're both under a square root, right? So that's going to be the square root of 21. It doesn't simplify, and so we're finished, right? That's all we have to do. And then on this next one, I'm going to multiply 2 times 5 and x times y. And once again, it won't simplify. So if I've got expressions that contain radicals, the radicals are both square roots, I multiply what's underneath. Okay, so we're going to use that as we work through rationalizing denominators. So we start with rationalizing denominators having one term, right? So they've got one term in the denominator. And so based on what I just showed you, if I want to get that, basically rationalizing denominators is getting the radical out of the denominator, okay? So to do that, I would multiply radical 2 by radical 2, right? The square root of 2. Because I just showed you on the previous slide that if I multiply the square root of 2 times the square root of 2, it's 2, and then I won't have a radical in my denominator. But if I multiply my denominator, then I also have to multiply my numerator, because when I multiply by the square root of 2 over the square root of 2, I'm really multiplying by 1, right? So I'm not changing the meaning of this, but I am changing how it looks, right? So it's going to be equivalent, but it looks a little bit different than it did in the beginning. So I multiply what's under the radical, the 3 and the 2, right? And then in the denominator, that simplifies to just 2. I cannot simplify this because I have a 6 under a radical and a 2 that's not. So there's no way to combine those and simplify. All right, so let's look at this next one. When you're faced with a radical like this, you can actually write it as radical 25 over radical y. We can always split those up. Now I know the square root of 25 is 5, right? So I'm going to be able to simplify that on the next step. I need to multiply by the square root of y over the square root of y. Now that's based on the denominator. So whatever it takes to get the radical out of the denominator is what I'll use. And then you see that I'm going to have, well, the square root of 25 is 5. I'm going to go ahead and write that. And then in my denominator, I just have y. And then that's it. Okay? So it's based on what it takes to clear out that radical in the denominator. All right, so on the next one, I have the square root of 11. So I'm going to multiply by radical 11 in the denominator, which means I do the same in the numerator. and then I'm left with a denominator that's just 11. I've cleared my radical. If you can hear snoring, that's my pug. Yes, yes, he's laying right over there snoring away. So, okay. So we've got -5 times the square root of 22, right? 2 times 11. I'm going to multiply this, right? And then I can multiply the square root of 11 times the square root of 11, which is 11. And then that's it. Now you can write that negative sign out in front of the bar, right? I can write it like this. 5 radical 22 over 11. And then that's it. Okay. You didn't have to rewrite it. I was just showing you could write it in a different way. All right, next. Now it gets a little more complicated. If the radical if the number under the radical in the denominator needs some simplifying, then we're going to do that. And as you can see, 45 is 9 times 5. Okay, so first, you always want to simplify if you can. It just makes it less complicated. You really don't want to rationalize unless you have simplified. So in the denominator, I'm going to have 3 radical 5 because I'm able to simplify the square root of 45 this way. And then I'm going to multiply by the square root of 5. Right? Remember, I'm going to match my radical when I'm working with square roots. Okay, so now in the numerator, I'm going to have 55y under my radical. And then in my denominator, I'm going to have 3 times 5, right? Because if I multiply the square root of 5 times the square root of 5, it's 5. 5 times 3 is 15. And that's it, right? I've got it simplified. Okay. Next, same kind of denominator. It needs some simplifying first. 32 has a couple of square roots. One is 4, one is 16. 16 is the better choice because you want the largest perfect square that you can find, the largest perfect square factor, right? So did I square it? Oh, there's 2 factors of 32 that are perfect squares. I don't know how I said that the first time. Anyway, so when I simplify it, right, simplify that radical, I'm going to have 1 over 4 radical 2x. And then I can rationalize. Okay, so I multiply by the same square root, whatever it happens to be, in this case 2x. And then write my answer. So I'm going to have radical 2x in the numerator because we're just multiplying by 1. In the denominator, it's 4 times 2x, which is 8x. And once again, don't be tempted to simplify any further because the 2x is under the radical, 8x is not. So we can only simplify them if they were both in the radical. All right, here's the next one. Now this is where it gets a little more complicated also because now we're on a cube root. So the fact is that I have a 9 here and I can break the 9 down to be 3 squared. Now, in order to clear the radical, right, I have to have an exponent under the radical that matches my index of 3. So I've got 3 to the second power, but I need one more 3. So that means I multiply by the cube root of 3 to the first power, right? My goal is to have 3 of those, which also makes 27. If you take 3 squared, or 9 times 3 is 27, the cube root of 27 is 3, and so that's the point of this, right? Because I'm trying to get a number in my denominator that does not have a radical. Okay. Trying to decide on that can be the most confusing part. So in my numerator, I'm going to have 5 times the cube root of 3. But in my denominator, I'm going to have just 3. Because remember, this is going to be the cube root of 3 cubed, or the cube root of 27, which is 3. Okay, so next I'm going to write this one first as the cube root of 7 over the cube root of 10. Now I have 10 to the first power. 10, we can't break 10 down in any way as a power, writing it with some power. That's not possible. So I need 10 to the third power to be able to simplify my radical in the denominator. So I multiply by the cube root of 10 squared. So that gives me 10 to the third power, or 1,000. The cube root of 1,000 is 10. And then in the numerator, I'm multiplying by the same thing. Now, 10 squared is 100, right? So when I multiply in my numerator, I'm going to have 7 times 100. I'm not very good at making these radicals. 7 times 100 is 700. My denominator is going to be just 10. That's how I set it up so that I could simplify that denominator and get the radical out of there. Okay. All right, so that is the final answer, the cube root of 700 over 10. And now we're going to go on to some information you will need to rationalize denominators having 2 terms. Now to do that, we're going to use something called conjugates, and we actually talked about conjugates back in chapter 5 when we were talking about the sum and difference of squares. Those are actually conjugates whenever you have it in this form, right? A plus B times A minus B. The A plus B is the conjugate of A minus B, and vice versa. And so you'll notice that it's still an A and a B, but my signs are opposites. And if you look at each one of these, right, I have a negative and a positive, positive, negative, positive, negative, but everything else matches besides that. So we can write a conjugate if we know our denominator. All right, so let's just go through a few of these and multiply them. Now, based on the fact that we get this shortcut, remember we only have to multiply the A times A and B times negative B. And that means I'm going to have x times x, negative 5 times 5, and then that's it. So it's a quick multiplication, and we're going to use this when we're rationalizing denominators and numerators that have 2 terms. So it'll be a fairly quick process. We have radical 3 times radical 3, 7 times negative 7. And here's the whole reason why we're going to do this. Notice I multiplied this. Now I don't have a radical, and that's the point, right? We want to remove the radical from our denominator or numerator, depending on which one we're working with. And so then we're just going to get a nice number here, which is negative 46. And so that's the whole point of this. We multiply, and then we don't have a radical anymore. So let's look at the next one. If I multiply 3 radical x times 3 radical x, that's simply going to be 9x. 1 times negative 1 is negative 1. And that's pretty quick, right? Remember, when I multiply radical x times radical x, it's just x. 3 times 3 is 9. And so that's it. On the next one, right, we're going to multiply the radical x times radical x and multiply the radical y's. So we get x minus y. And then we're going to use this to work with the next concept on the next video. All right, so that's it for now.